4.5 billion years ago. That's where it all starts, and our solar system began to form. Out of a cloud of hot dust and gas, particles began to condense and collide with each other, forming the start of planetary embryos that we call protoplanets. But the process isn't as simple as it sounds, and has led to a key question in planetary science of how do we build planets? Now, a lot of these early planetary embryos got destroyed during the formation of our solar system by getting too close to the sun and crashing into it, or too far away from the sun's gravity and leaving the solar system altogether. Some protoplanets even collided with each other, leaving us only with the planets we see today. However, some of these protoplanets there are still remains of, in the form of meteorites and asteroids. And that is the aim of my research, is to use meteorites to gain more of an understanding of the early solar system and its protoplanets. I'm looking at a type of meteorite called an achondrite. Now, achondrites are known for being similar to the rocks we find on Earth, coming from the outer shell of these now destroyed planets, giving us an insight into more about the geological history of these protoplanets. By studying the meteorite fragments that are left of these protoplanets, we can learn more about them and the earliest period of the solar system's history through studying the crystals and mineralogy inside these meteorites. This is sometimes known as the petrology of the rock. Now, when it comes to planet formation and the size of the planets and the early solar system itself, there are a lot of questions out there. But by learning more about how planets form can help us in understanding our own solar system, as well as other solar systems and what has led to their formation. My research will use a technique known as an electron backscatter diffraction, which fires an electron beam at the sample, providing an in-depth microscopic image of the meteorite's crystallography and structure. The images produced can look something like these ones. These are 3 electron images of 3 different types of achondrite meteorites that I'm studying as part of my research. And as you can see, they all look rather different because just the same way we have different types of planets now, you used to get lots of different types of protoplanets too. From images like this, I'm able to figure out what the rock is formed of and what has happened to it since, allowing me to reconstruct the geological history of these meteorites and helping to answer one of those key questions in planetary science of how do we build planets? By comparing the petrology and microstructures of these meteorites to the rocks we find on Earth, we're able to provide a more in-depth and complete image of the rocky planets, both in our solar system and beyond.